This video is all about the power series. Good day! Today we are going to discuss the radius and interval of convergence of a power series. To start with, I have here different examples to prove the theorem number 3. So in theorem number 3, it says there that if the absolute value of x minus c is less than r, it will converge. But if the absolute value of x minus c is greater than r, then it will diverge. So, ang gagamitin natin dito is the first statement. So, where x is equal to c, or our constant. So, let's start with our first example. We have here, if the series of x minus 2 raised to n over n plus 1 times 3 raised to n from as n is equal to 0 to infinity. Dito ang gagamitin natin ay ratio test. So, we have here the limit. Tanda pa ang ratio test. X minus 2 raised to n plus 1 over n plus 1 plus 1 times 3 raised to n plus 1. And then, ita-times natin siya, or i-multiply sa reciprocal no given. So, we have n plus 1 times 3 raised to n over x minus 2 raised to n. To solve this, we are going to break down the factors na pwede nating i-break. And so we have dito, meron tayong x minus 2 raised to n, x minus 2 raised to 1. Tapos, so meron tayong x minus 2 raised to n dito. So, cancel the x minus 2 raised to n. And then we have n plus 1 here. N plus 1. And then the 3 raised to n. This will become 3 raised to n and 3 raised to 1. So, 3 raised to n will be cancelled. So, ano na ba ang natira? As n approaches infinity. So, the limit as n approaches infinity, we have, sa numerator natin ay, meron tayong x minus 2 raised to 1. So, hindi na natin nilalagay yon. And then, sa denominator ay, since may 1 pa dito, and may 3 pa dito, 1 times 3 will be 3. As the limit of n approaches infinity, absolute value of x minus 2 over 3. So, hindi pa dito natatapos ang lahat. Ilalabas natin yung 1/3. Leave natin yung x minus 2. So, we have 1/3 is the limit n approaches infinity of the absolute value of x minus 2. Kukunin natin ngayon yung interval of convergence ng ating series na ito. So, isulat natin yung sagot dito. Bago natin burahin, we have 1/3 limit n approaches infinity of the absolute value of x minus 2. Para mahanap natin ang interval of convergence, so sinasabi dito na kapag ang row is less than 1, ang row kapag the absolute value of x minus 2 is less than 3. Here, the absolute value of x minus 2 is less than 3. So, tama siya, diba? Less than siya. So, to compute the interval of convergence, panggigitnaan lang natin yung x minus 2 and then 3. Since positive dito, lalagyan natin sa kabila ng negative 3. So, to cancel yung kasamang constant ng variable na x, so we have to add 2 here, add 2 there. So we have, ang natira ay x is less than 5 but greater than negative 1. So our interval of convergence is negative 1 and 5. So, pakitandaan natin, are. Kasi gagamitin natin siya to measure the series or to prove that the series, if the series converge or diverge using the ratio test. Ano natin dun eh. I is equal to negative 1 and 5. Para matest natin kung ang interval of convergence na ito is kung nag-converge nga ba dito sa series natin or nag-diverge. So, the values of this will serve as the values of x. Isa-substitute lang natin siya sa value ng x to the given. So, we have here, let's test for x is equal to negative 1. So, this series as n is equal to 0 to infinity of x minus 2 raised to n. This is our given. N plus 1 times 3 raised to n. So we're going to plug in the negative 1 value to x. So we have negative 1 minus 2 raised to n over n plus 1 times 3 raised to n. And then negative 1 minus 2 is negative 3 raised to n over n plus 1 times 3 raised to n. So, itong numerator natin, pwede natin siyang i-break down pa into the series n is equal to 0. Don't forget 0 is equal to 0. Infinity. This will become, so we have 1 here, negative 1 raised to n and 3 raised to n. and then the n plus 1 times the 3 raised to n. So canceling the 3 raised to n, we have as n is equal to 0 to infinity, we have negative 1 raised to n over n plus 1. So as you can see, the answer that we got is an alternating series. Okay, because of the negative 1 raised to n, it's alternating. And 1 over n plus 1 is, so we have here n is equal to 0 to infinity of negative 1 raised to n over n plus 1 is equal to, so if we plug 0, we got here 1 over 1. So it will become 1. And then the next value will be, we have 1 here, so negative 1 over 2. Negative 1 over 2. And then for the third one, we have plus, so plug in the 2 for n, we have 1 over 3. Positive. It's alternating. Should answer that. So when we have an alternating series, we can say that this, the value for x is equal to negative 1, the series converge. So if it converge, we have brackets here, bracket. And pag nag-diverge, we'll put a parenthesis. So let's try the other values of x. For x is equal to 5. So we have here the series of n is equal to 0 to infinity of x minus 2 raised to n over n plus 1 times 3 raised to n. So plug in natin yung 5 sa x. So we have 5 minus 2 raised to n over n plus 1 times 3 raised to n. And then 5 minus 2 is equal to 3 raised to n, and n plus 1 times 3 raised to n. So cancel the 3 raised to n. You've got the answer as the series of n is equal to 0 to infinity of 1 over n plus 1. So this is our answer. And 1 over n plus 1 is, it will diverge. Why? Because the following infinite values of this series would be 1. So plug in 0, we have 1. We have, if we have 1 here, 1 plus 1 is 2, so 1/2. We have 2 here, 2 plus 1 is 3, we have 1/3. And so on and so forth. So this series diverge. Again, if it diverge, this will have a parenthesis. We identified the interval of convergence. And if the value of x is equal to -1, we will get the series diverge, or converge rather. And if we have as x is equal to 5, the series diverge. What about its radius? Let's place it here. Radius. It says that 1 over r, the absolute value of x minus c, is less than r. So in this situation, the series will converge as x is equal to c, or the constant value. And then our radius here will be equal to, so if we were to this is what we got. We are going to look this answer will look like this, isn't it? So I have here 1 over 3, the absolute value of x minus 2 is less than, so in here r, so the value of r is 3, so our radius would be 3.
So for the first example and the third theorem, the series of n starts from 0 to infinity is square root of n times x minus 1 raised to n. So perform ulit tayo ng ating ratio test. Ang ating use of n is the square root of n times x minus 1 raised to n, at ang ating use of n plus 1 is the square root of n plus 1 times x minus 1 raised to n plus 1. So, substitute natin. The limit as n approaches to infinity is square root of n plus 1 times x minus 1 raised to n plus 1 over square root of n times x minus 1 raised to n. So, dahil parehong may square root ang ating numerator at ang ating denominator, so ibubukod natin siya, square root of n plus 1 over n, then yung nakabukod na isa, which is x minus 1 raised to n, times x minus 1 raised to 1 over x minus 1 raised to n. So, makakancel natin ang x minus 1 raised to n, and ang matitira na lang is x minus 1 raised to 1. So, limit as n approaches to infinity, the square root of n plus 1 over n, and x minus 1. So, in square root of n plus 1 over n, makakancel natin ang n. So, ang matitira natin is 1. So, 1 times x minus 1. Ratio rho is less than 1 if x minus 1 is less than 1. So, dahil less than 1 ang kasama ng ating x minus 1, so ilalagay natin siya both side. So, negative 1 less than x minus 1 is less than also in 1. So, yung x minus 1 natin, so magiging positive siya. I-add natin siya both sides. So, siya ay magiging 0 less than x less than 2. The ratio rho is greater than 1 if x minus 1 is greater than 1. Therefore, the series diverges if x is less than 0 or x is greater than 2. So, the ratio test is inconclusive if rho is equal to 1. The ratio rho equal to 1 if and only if the x is equal to 0 or x is equal to 2. For x that is equal to 0, so yung original equation natin, papalitan natin yung x ng 0. So, ang magiging kalabasan niya is the series of n starts from 0 to infinity, square root of n times negative 1 raised to n is equal to 1. So, it diverges. So, for the x that is equal to 2, so our original equation is papalitan ulit natin ang x ng 2. So, ang magiging kalabasan is the series of n that starts from 0 to infinity is square root of n times plus 1 raised to n is equal to 1. So it diverges. So the interval of convergence is from 0 to 2 and our radius is 1. For our last equation, the series of n starts from 0 to infinity x minus 5 raised to n over n raised to 2. So ang ating use of n is the x minus 5 raised to n over n raised to 2 at ang ating use of n plus 1 is x minus 5 raised to n plus 1 over n plus 1 raised to 2. So, perform natin ang ating ratio test. Ang ating x minus 5 raised to n plus 1 is magiging x minus 5 raised to n times x minus 5 raised to 1. So, makakancel natin ang x minus 5 raised to n at ang magiging tira natin is the n raised to 2 times x minus 5 over n plus 1 raised to 2. And again, ilalabas natin ang ating x minus 5. So, x minus 5 limit as n approaches to infinity, n over n plus 1 raised to 2. So, makakancel yung n sa n over n plus 1 raised to 2. So, magiging 1 na lang siya. So, ang magiging answer natin is the x minus 5. The ratio rho is less than 1 if x minus 5 is less than 1. So, ang ating x minus 5 is less than 1. So, ilalagay natin ang 1 sa both sides. So, magiging negative 1 less than x minus 5 less than 1. So, ang ating x minus 5. So, dahil minus 5 siya, magiging positive. At i-add natin siya both sides. So, ang magiging kalabasan is 4 less than x less than 6. The ratio rho is greater than 1 if x minus 5 is greater than 1. Therefore, the series diverges if x is less than 4 or x is greater than 6. The ratio test is inconclusive if rho is equal to 1. The ratio rho equal to 1 if and only if x is equal to 4 or x is equal to 6. So, for the x that is equal to 4, so katulad nung kanina, yung original equation natin is papalitan natin yung x ng 4. So, ang may equation natin is the series of n starts from 0 to infinity, negative 1 raised to n over n raised to 2 is equal to 0. So, it converges. Next is, ang ating x is equal to 6. So, ganun din ang gagawin natin. The series of n starts from 0 to infinity is 1 over n raised to 2 is equal din sa 0. So, mag-converge din siya. So, ang ating interval of convergence is 4 to 6 at ang ating radius is 1. So, this is the end of the topic 6, which is radius and interval of convergence. Thank you and God bless. Bye-bye!
Let's take another example na ibinigay sa atin ng ating professor, si Sir Richmond Jet Marasigan. Nasagutan sa ating midterm. And that would be the series as n is equal to 1 to infinity of negative 1 raised to n times n over 4 raised to n times x plus 3 raised to n. So, let's do it. The limit as n approaches infinity of negative 1 raised to n plus 1 divided by over 4 raised to n plus 1. Oh, I forget the n plus 1 times x plus 3 raised to n plus 1. So, dito, para hindi tayo masyadong malito, isama na natin ito sa numerator. Ganun din naman yan. So, let's rewrite it. We have here negative 1 raised to n plus 1 times n plus 1 times 3 plus oh, times x plus 3 raised to n plus 1 over 4 raised to n plus 1. And then, ita-times natin siya sa reciprocal ng given. So, we have 4 raised to n. So, our numerator. 4 raised to n over you have negative 1 raised to n times x plus 3 raised to n. And don't forget the absolute value. So, paano ba breakdown? Yung sinasabi ni Ma'am Michelle na breakdown na yan. So, ganito po iyon. In negative 1 raised to n plus 1, i-breakdown natin siya into negative 1 raised to n times negative 1 raised to 1. And then, times n plus 1 times x plus 3 raised to n times, i-breakdown din natin siya, x plus 3 raised to 1 over 4 raised to n times 4 raised to 1. Nakuha na ba? Pag-breakdown. Sanay na kayo dyan. Sure. Negative 1 raised to n times n, then x plus 3. Kaya natin ginagawa yung breakdown na yan ng mga expressions natin para makancel natin yung mga hindi na kailangang mga bagay-bagay. So, dito makakancel natin ang negative 1 raised to n, the x plus 3 raised to n, and the 4 raised to n. Ayan. May nakaligtaan pa ba? Wala naman na siguro. We have here the limit of n as n approaches infinity, the absolute value of. So, nagtira sa atin ay negative n plus 1. So, yung negative na lang natin yung negative 1 raised to 1. Same value lang. And then the x plus 3 raised to 1. Huwag na natin isulat yung raised to 1. Over, wala naman na natira dito. And then may 4n pa dun. So, 4 times n. Here, 4 and then n. Okay? So, as what we always do, so we have here, ilalabas natin tong x plus 3 doon. So, x plus 3, the absolute value of x plus 3 as the limit of n approaches infinity of, since kukunin natin yung absolute value ng negative n plus 1 over 4n, so, magiging positive na siya. N plus 1 over 4 times n. And then, so let's continue here. We have x plus 3 times the limit as n approaches infinity of n plus 1 over 4 times n. So, meron na tayo dito ngayon. As we plug in the infinity here, this will go to infinity. The n will go to infinity. So, we've left the 1/4. Right? Here, 1 and then 4. And then the x plus 3. So that's it. No, it's not. So let's write here what we've got. We have 1/4 times x plus 3. So katulad na sinabi ko kanina, sa pagkuha natin ng interval of convergence, para malaman natin kung nag-diverge ba siya or nag-converge into the original series. So we have here this one. So if the row is this, if the row is less than 1, we have x plus 3, the absolute value of x plus 3 is less than 4. And ganyan lagi pag ang row is less than 1. So, kapag ganito yung expression na natin, nag-converge siya. Okay? And then, if we were going to find the interval of convergence, we have x plus 3 less than 4. And then sa kabila is greater than negative 4. Since it's positive here, we're going to negative there. So, to cancel this 3 na kasama ng ating x na variable, we have 2 minus 3 para makancel siya. So, minus 3 sa kabila, minus 3 din sa kabila. So, nakuha natin is x is less than 4 minus 3 is what? 1. And then x, and then greater than negative 4 minus 3 will be negative 7. Okay, we have the value. We have the interval. The values of interval, let's copy it here. Interval of convergence is equal to negative 7 and 1. Let's test if it will converge or if it will diverge. So let's take x is equal to negative 7. So diretso plug in na lang natin. Ano? So we have n is equal to 1 to infinity. We have negative 1 raised to n times n over 4 raised to n. So dito lang naman natin siya substitute. So we have negative 7. Here we have x, so negative 7 plus 3 raised to n. What will happen next? So we have to solve this. Negative 7 plus 3. So we have negative 1 raised to n times n over 4 raised to n times negative 7 plus 3 will be negative 4 raised to n. Again, paano nga tayo mag-breakdown ito? We have negative 1 raised to n, and then 4 raised to n. So, makukuha nating series ay as n is equal to 1 to infinity, we got negative 1 raised to n times n over 4 raised to n times negative 1 raised to n times 4 raised to n. Let's erase this. We have cancel the negative 1. No, the 4 raised to n. And ang natira sa atin is negative 1 raised to n times negative 1 raised to n times n. So, dito, itong negative 1 raised to n and negative 1 raised to n, ang magiging value niya is negative 1 raised to 2 times n, which will be equal to 1. So, our series for x is equal to 7. Our series n is equal to 1 will be, so ito ay 1, so we have n. N na lang natira. So, if we were to know the values of the series, we have 1, 2, 3, 4, and so on and so forth. So, it will diverge. This will diverge. Next, let's test the value as x, the series as x is equal to 1. So, diretso plug in ulit natin. We have negative 1 raised to n times n over 4 raised to n times, plug natin yung 1 sa x. So, 1 plus 3 raised to n. So, this will become 1 plus 3 is 4. So, we have negative 1 raised to n times n over 4 raised to n times 4 raised to n. Cancel the 4 raised to n. We have left n is equal to 1, infinity of negative 1 raised to n. Oh, taas masyado. Negative 1 raised to n times n. So, yun yung nakuha nating series. Where x is equal to 1. In which, ang value ng series na ito ay does not exist. Bakit? If we plug in 0, we have 1 times 0, we got 0. And if we have 2 here, for example, 2, you get 1 times 2. So it doesn't exist. So it will also, no, it does not exist. It will not converge or diverge. Does not exist. So in this power, or in this case, the power series will not converge for either endpoint. Let us now move on for our last topic, which is representation of a power series as a function. So, ito yung representation ng function. And then, sa power series naman, we have the summation of n is equal to 0 to infinity of x raised to n. Since ang x natin is, kinuha lang natin yung series, x and then raised to n, where the absolute value of x is less than 1. For that series to converge, this is the power series of this function situation. The absolute value of negative x cubed will converge if it is less than 1. So, sa pagkuha natin ng interval of convergence, again, we have here, so pag may exponent yung nasa loob, hindi natin kailangan isama pa yon. Ano? So, we have x is less than 1 but greater than negative 1. So, obviously, ang ating interval of convergence is r, negative 1, and 1. So, the interval of convergence of this series is the same as the original series, right? So, the given 1 plus x cubed has the series 1, yung sinubstitute natin dito kanina, negative x cubed, positive x raised to 6, negative x raised to 9. So, paano natin nakukuha ito? Ipa-plug lang natin yung values ng n. So, from 0, we got 0, so it will become 1. When 1, so it will become negative x cubed. Kapag 2, negative 3 times 2 is 6. So, positive x raised to 6. Kapag 3 times 3 is 9. So, negative x raised to 9. And the next is positive, and so on and so forth. So, that's the power series for this function. So, we have here the function of x squared over 4 minus x squared. So, again, gagawin natin siyang kamukha nito. 1 minus x. 1 over 1 minus x. Para malaman natin kung ano yung power series ng function na ito. So, first, we have, so, paano ito? Parang ang hirap. For ito, dapat ay 1, and then sa numerator ay dapat ay 1. Bakit may x squared doon? So, i-divide natin siya sa 4. Para maging 1 ito. So, we have x squared over 4 all over 1 minus x squared over 4. And then, ito pwede pa nating i-simplify. So, we have say x over 2 raised to 2. Since it will become x squared and then 2 times 2 raised to 2 is 4. So, similar value. Sinimplify lang natin. So, ang x natin dito ay the x minus x over 2 raised to 2. So, ito pag ginawa natin sa power series, ay magiging x raised to n. So, ang x natin dito ay, so we have here the series as n is equal to 0 to infinity of, meron tayong x squared over 4 sa numerator. So, isasama natin siya times etong x over 2 raised to 2 times n, since may n pa doon. So, ito yung series na nakuha natin. Hindi pa nagtatapos dyan ang lahat. Kung sasama-samahin pa natin ang kanilang mga x's. So, we have n infinity. The series of, so, paano natin sasamahin ito? So, we have x raised to 2 times n plus 2. Tama? And then, it will become 2 raised to 2n is 4 raised to n. So, we have 4 raised to n plus 1. So, ang nakuha nating power series is the series n is equal to 0 to infinity of x squared over 4 times x over 2 raised to times n, in which the absolute value of x, which is x over 2 raised to 2, is less than 1 for the series to converge. So, inote lagi natin na kapag itong x over 2 raised to 2 is equal to 1, so, it does not converge. Kailangan lagi nating hanapin yung convergence niya. So, solving this inequality, makukuha natin, we have 1/2 since x over 2, and then the absolute value of x squared is less than yung pagkuha natin ng interval of convergence kanina. So, is less than 2. So, we have here x less than 2 but greater than -2. So, obviously, our interval of convergence are -2 and 2. So, that's our interval of convergence. And then, -2 and 2. And kopyahin din natin ito doon. So, we have the series nakuha natin kanina. Katulad din siya nito. Pinasimplify lang natin. So, we have x. Pinagsama-sama yung mga x's. 4n plus 1. So, sa series na ito, we have the values x squared over 4 plus x raised to 4 over 4 raised to 2 plus x raised to 6 over 4 raised to 3 plus and so on and so forth, in which yung values ng x natin is less than 2. So, it will converge. These are the interval of convergence. Thank you.